All right, so on number 9, one of the first things that I want to talk about is how to show that things are similar. We had 3 types of similarity. We had angle-angle similarity. We had side-angle side similarity. And we had side-side-side similarity. So one of those 3 we're going to have to find in this picture to show that these 2 triangles are similar. And one of the things that you just said a moment ago is that because JK and QR are parallel, we can draw a Z. And that means that angle K and angle R are congruent because they're alternate interior angles. Angle K is congruent to angle R because they are alternate interior angles. There's another pair of angles up there that I could mark as congruent even if I did not know about the parallel lines.
Oh.
What is the pair of angles that I could mark as congruent?
JZK and RZQ.
JZK and RZQ. Angle JZK is congruent to angle RZQ. Why? They're vertical angles, yes. And just to be really transparent, I don't need the vertical angles to do this. Just like I got angle K and angle R with alternate interior angles, if I had drawn my Z the other way, so I still went over KJ, but then I went along JQ and then QR, so if I'd drawn that other Z, I could have found that angles J and Q were congruent. And so I could get another pair of angles that way. But I only need 2 pairs of angles. I have 1 pair right here and 1 pair right here. And so that gives me angle-angle similarity. So my final answer here would be that triangle JKZ is similar to triangle QRZ by angle-angle similarity. Right. What other problems from the review between 7 and 18 would you guys like me to go over?
12.
Number 12, absolutely. All right, number 12. Tells me up at the top that VR, here's VR, VZ, here's VZ, and ZR, here's ZR, are mid-segments. That means that V, Z, and R are midpoints. That means UV and VY are congruent. UZ and ZW are congruent. RW and YR are congruent because we have these midpoints. When we talked about mid-segments of triangles, one of the properties that we discussed is that if I have the mid-segment of a triangle and the side of the triangle that is parallel to that mid-segment, the side of the triangle is twice as big as the mid-segment. So that means UV would be 25 and VY would also be 25. So if I want to find the length of UY, that would be 2 times ZR. So X is equal to 2 times 25, or X is equal to 50. Because ZR would be congruent to UV and VY. What else would you guys like to see? Which one? 11, absolutely. If AB equals 6, BC equals 4, AE equals 9, find ED. Are you guys okay if I call ED X?
Yes.
All right, so on my picture, I'm going to put an X there for ED. We have a parallel pair of lines here with EB and DC. When I have parallel lines like this with the triangle, I can look at one side here and turn that into a ratio, a proportion. So I can write a proportion that is 6/4. And that is proportional to, so that proportion is equal to, and then I go to the other side, and I'm going to make a proportion out of this here. Since I put the 6 on top of the other fraction, what would have to go on top of this second fraction? The 9 has to go on top. So 9/x. So now we need to solve this for x. We've got two fractions here, so I'm going to have to get rid of both fractions one at a time. Let's get rid of this fraction first. So I'm going to multiply both sides by x. It's going to cancel out my denominator on the right. Over on the left, the x only multiplies to the numerator. So I would have 6x/4 equals 9. Then we're going to get rid of our second fraction by multiplying both sides by 4. Cancels out my denominator on the left. So I have 6x equals what? Six equals, what'd you say? Not 36, yes. 6x equals 36, because 9 times 4 gives me 36. Next thing I need to do is what? Divide both sides by 6. 36 divided by 6 gives me what? 6. So ED is 6. What other problems would you guys like me to work through? Number 10? Absolutely. Determine if the triangles are similar. If yes, write a similarity statement and reason. If not, explain why. So one more time, the three types of similarity that we have are angle-angle similarity, side-angle-side similarity, and side-side-side similarity. There's something that I know I can get right off the bat before I look at any numbers or anything else. What's something that I can mark on the picture? Vertical angles. So we have this angle here, congruent to this angle here. So angle AEB is congruent to angle CED because they are vertical angles. Do we have information about all three sides of both triangles?
No.
No. So which one of the three types of similarity am I probably not going to be able to use?
Side.
Can't use side, side, side because I don't know about all three sides on both triangles. I just found an angle, so I've got one angle for angle, angle, or I have the angle for side, angle, side. Do we know anything about parallel lines? Do we know anything about other pairs of angles?
No.
No. So are we going to be able to use angle, angle?
No.
Probably not. So now I need to look at my sides. This triangle up here, ABE, has a side that is 4 and a side that is 6. And my bottom triangle, CED, has a side that is 12 and a side that is 8. I need to see if the sides are proportional to each other from one triangle to another. And so I need to set up two proportions to see if we come out to be the same. So I'm going to match the smallest side on the top triangle to the smallest side on the bottom triangle. What are the smallest sides on these two triangles? 4 and 8. So I'm going to make a proportion. I'm going to make a fraction with 4 and 8. It does not matter which one I put on the top. I just have to stay consistent with my next fraction. If I put small triangle in the numerator, small triangle has to stay in the numerator. If I put large triangle in the numerator, then large triangle has to stay in the numerator. So I put the 4 in my numerator. That came from which triangle? The top one. What's the other side that we know from that top triangle? 6 over 12. I have to see if these come out to be the same. 4 over 8 reduces down to what? 2/4, or I could reduce it all the way down to what? 1/2. If I divide top and bottom by 4, I get 1/2. What about 6 over 12? What does that reduce down to? 1/2. Did they come out to be the same?
Yes.
Yes, so they are proportional. The sides are proportional. So are these triangles similar? Yes, using which type of similarity? SAS, side, angle, side, similarity. And now we need to write our similarity statement. So we're going to write triangle whatever is similar to triangle other one. So I need to name my first triangle, and it does not matter the order that I name my first triangle in, but the second triangle order does matter because I have to make sure that I'm matching up the similar parts. What do we want to call the first triangle? AEB works for me. AEB is similar, so that just gets a single squiggle, to triangle. Let's look here now. AE was this side right here, the side that was 4. That was my smallest side, right? What's the smallest side on the other triangle?
D.
D is a point. What's the smallest side?
Oh, ED.
ED right here. So this next bit either needs to be ED or DE. Order matters here. So I have to be careful. What are the angles that we have that are congruent?
AEB and
Yep.
CED.
AED, or AEB and CED. With the point in the middle, the vertex is what? What is the vertex of that angle? E. So I have to make sure, since E was in the middle of the first triangle name, E has to be in the middle of my second triangle name. So this has to be DE. And then what's the other letter then?
A.
DE, not A, that's not part of the same triangle. C. DEC. Because we have to have E in the middle. We have to make sure to match up the proportional pieces. What else would you guys like to see? Which one? 18. Absolutely, we can go look at number 18. 18 is the last one that is in this section. Number 18 says to find the lengths of the sides using special right triangle rules. If this isn't something that's on your cheat sheet, you should get it there, ASAP. So special right triangle rules. We had two types of special right triangles. We had 45, 45, 90 triangles. And we had 30, 60, 90 triangles. A 45, 45, 90 triangle is also called an isosceles right triangle. What does isosceles mean? Two sides are equal. Because I have two congruent angles. I know I have two congruent sides. Single rule here, the hypotenuse is equal to the leg times the square root of 2. And then we had two rules for our 30, 60, 90 triangles. With a 45, 45, 90, two of the sides are the same. And so we have two legs that are the same size and a hypotenuse. We either know how big those two legs are and we're finding the hypotenuse, or we know how big the hypotenuse is and we're going to use that to find the lengths of both legs. With a 30, 60, 90, all three sides are different sizes. So we have to have two rules here. The hypotenuse is equal to 2 times the short leg, and the long leg is equal to the short leg times the square root of 3. All right. So let's look at part A. Is part A a 30, 60, 90 or a 45, 45, 90?
30, 60, 90.
30, 60, 90. Here's the 30 degrees. Here's the 90 degrees. Triangle sum theorem tells me that this angle up here has to be 60, because 60 plus 30 is 90, plus another 90 gives me 180. Now I need to know what my sides are. Which side up here is the hypotenuse? X is the hypotenuse. And then we have short legs and long legs. Which of the remaining sides would be my short leg? Square root of 6, yes. Opposite the smallest angle will be the short leg. So opposite the 30-degree angle is my short leg. That means y is the long leg.
So it's always the case for the short leg to be the opposite of the smallest angle?
The smallest side of a triangle is always across from the smallest angle.
Okay.
Yep. Biggest side of a triangle is always across from the biggest angle. All right, we need to find x and y here. X is our hypotenuse, so I'm going to use the hypotenuse rule. Hypotenuse equals 2 times the short leg. The hypotenuse is x. X equals 2 times short leg here is how big? Square root of 6. That is as simplified as we can get this. 2 times the square root of 6 would be my fully simplified answer here. I think that's coming from the next room. Do you guys hear that?
Yeah.
I don't see it in here anywhere. I think it's coming from one room over. I'm not sure. I can't get any closer to the noise. If anybody finds a missing phone, please let me know. All right. So we still need to find y here. Y is my long leg. Our rule for long leg is long leg equals short leg times radical 3. So the long leg is y. The short leg is radical 6 times radical 3. When we have two numbers that are both under their own separate radicals and they're being multiplied together, we take those two numbers and we multiply them together underneath the radical. So this would be y equals the square root of, and then we times 6 and 3 together here. What is 6 times 3? 18. So y is the square root of 18, but I have to know whether or not I can simplify that anymore. So we're going to need to try to simplify the square root of 18. So I'm going to bring that over here, square root of 18. What numbers will go into 18? 2 and 9. So instead of square root of 18, underneath here I could have 9 times 2, right? Or 2 times 9. It doesn't matter the order I put it in.
Yes.
Can either of those numbers be broken down anymore? Is there anything that goes into 9?
Yes.
What goes into 9?
3.
3 and 3. So this would be 3 times 3. Does anything go into 2? No, just itself and 1. So 3 times 3 times 2 would be 18. I have a pair of 3s right here. So that brings it out to the front. So the 3 is going to be on the outside. The 2 doesn't have a partner, so it has to stay underneath the radical.
So in situations like that, so should we always try to simplify it to the point where it's formatted in radical form, like how y ended up being 3 2 squared?
3 square root of 2.
3 squared root of 2. Do we always need to do that?
You always need to try to simplify your radicals, yes.
Okay.
Yep. The directions up here said that answers must be in radical form. Radical form means no decimals. That's why I didn't just pop it into my calculator and asked what we got, because the directions say has to be radical form. So my answer is either going to be a whole number or it's still going to have a square root in it. All right. So that's part A. Part B, what type of a triangle do we have in part B?
45, 45, 90.
45, 45, 90. Here's 45, here's 90. Triangle sum theorem tells me this other angle down here has to be 45 degrees. All right. A 45, 45, 90 triangle has how many sides that are the same? 2. Is the hypotenuse ever the same as another side? No. Hypotenuse always has to be the biggest, and it will never be the same size as another side of the triangle. So which 2 sides would have to be the same then? U and V have to be the same. So we need to find one of them, and if we find one of them, we've automatically found the other one. We had our rule, hypotenuse equals leg times radical 2. We don't have a short leg and a long leg with a 45, 45, 90 because the 2 legs are the same size. There's not one that's shorter or longer than the other. Which side up here is the hypotenuse? 10 square root of 2 is the hypotenuse. So that's what I'm going to put in for H. 10 square root of 2 equals, I have to pick either U or V that I'm solving for, but I know they come out to be the same, so it doesn't matter which one I pick. Are you guys okay if we go with U? I'm just literally going in alphabetical order here. U times radical 2. I need to get the U all by itself. How do we undo multiplication?
Division.
With division. So what are we going to divide by?
Square root of 2.
Yep, square root of 2. Over on the right, the radical 2 in the numerator and the radical 2 in the denominator cancel each other out. So I have just U left on the right-hand side. On the left-hand side, I have a radical 2 in my numerator. What's going on between the 10 and the radical 2 in my numerator? What operation is happening between the 10 and the radical 2? Multiplication. So the radical 2 in my numerator that's being multiplied to the 10 is also being divided by the radical 2 in the denominator. Do you remember how that canceled out on the other side? It's going to cancel out on this side also. And so we have 10 equals U. So U is 10, which means V is how much? V is also 10. I had a really good question first period that I want to touch on. They asked, what if it hadn't canceled out over on the left-hand side? So here's another example. If I had 10 radical 2 over, let's just pretend it was square root of 5 instead of square root of 2 on the bottom. How would we approach that problem? I can't leave radicals in my denominator. Does anybody remember what we do when we have a radical in the denominator like this?
We try to multiply by the denominator.
Yep, we're going to multiply both sides of the fraction by whatever the denominator is. So I would multiply top and bottom by the square root of 5. Up in my numerator, that would give me 10, and then square root of, and then I would have 2 times 5 underneath the radical, since the 2 and the 5 are both underneath the square root. And in my denominator, I would have the square root of 5 squared, because I have it times itself. What happens between a squared and a square root? They cancel out. The squared and the square root would cancel out. And so my numerator, I would have 10 square root of 10, and in my denominator, I would have 5. There's one last thing I would need to do here. These are both whole numbers, and so I would have to see if those simplify at all. Is there anything that goes into both 10 and 5? 2 doesn't go into both of them. 5 goes into both of them, though. Oops. Let me scoot all of this over. Come on. Sorry, I'm trying to scoot this over so that I have enough room to write my final answer. Nope, that is not what I wanted to do. There, finally let me scoot it over. So I would have 2 square root of 10 as my final answer here. All right. I have enough time for probably one more problem if we're going to get to the tests, looking at the tests today. What other problem would you guys like me to work through from this section?
15.
Number 15, absolutely. Problem number 15, find the value of x. How many sides of this triangle do we know the size of? Just one. Can I use Pythagorean theorem if I only know one side on a right triangle? No. You have to have 2 sides if you're going to use Pythagorean theorem. We only have one side, so I can't use Pythagorean theorem. Do I know anything else about this triangle other than that one side? I know an angle. So I'm going to circle this angle. This is where we're going to stand. We're going to label our triangle now. We have hypotenuse, opposite, and adjacent. Which one is the hypotenuse? 14 is my hypotenuse. X down here is which side, adjacent or opposite?
It's
adjacent. Because through the triangle to this side over here, that's how we get to the opposite side. All right, so then we have SOHCAHTOA. Which side of that triangle do we not know anything about? No variables, no numbers, no nothing.
the opposite side.
Opposite side. So which of these 3 do I have to throw out because it uses the opposite side? Sine and tangent. This one uses opposite, this one uses opposite. So process of elimination tells me we're going to use cosine. Cosine of the angle, 43 degrees, is equal to what? X over 14, yes. Adjacent over hypotenuse. What would I do to this to get the x all by itself?
Multiply by 14 on both sides.
Yep, multiply both sides by 14. Over on the right, that's going to cancel my denominator out. Make sure that whatever calculator you are using is in degrees mode. Cell phone calculators are typically not in degrees mode. The yellow calculators should all be in degrees mode. If you have any question about what mode it's in, you are always welcome to ask me, and I can make sure that the calculator is in the right mode for you. So when we do 14 times the cosine of 43 degrees, what do we get? 10.238. All right. That unfortunately wraps up all the time that I have to go over problems from this section. Your homework assignment for tomorrow is to finish out the remainder of the packet, modules 10 and 11. Finish out the remainder of the packet. I will take requests over that tomorrow, just like I did today. Monday and Tuesday, you have the entire day to work on your cheat sheet. I will also answer any other questions that you guys have individually, but I won't be leading anything on from the front of the room on Monday and Tuesday. So if there's any problems that we have not gone through that you need me to explain, I am more than happy to do that.